I'm Saritha Kumari, Assistant Professor, EEE Department, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Under the course Performance of Transmission Lines and Cables, today the topic is Power System Transients Introduction. Course outcome for which says analyze power system transients under different loading conditions of transmission line using circuit concepts and dual lattice diagram method. So we are going to see in this complete module unit the power system transients. So under different loading conditions of the transmission line using circuit concepts and another concept which is dual lattice diagram method. So this is a total module which under power system transients. So incident, reflected, refracted waves, okay, in the transmission line. So we come across this transients. So under that the concepts are, these are the various concepts: incident, reflected, refracted wave, types of system transients, traveling or propagation of surges, attenuation, distortion, reflection, diffraction coefficients, termination of lines with different types of conditions, open circuited line, short circuited line, T-junction, lumped reactive junctions, dual lattice diagram for all mentioned cases with the numerical problems. Then one more concept, this is different from the transients. This topic is different from the power system transients. So for the first part of the total module, so that is corona, which takes place in transmission lines. So what is this corona? So the corona description and factors affecting that, and under that the things like critical voltage, power loss, interference, and electrostatic electromagnetic interference with neighboring communication lines. So these are the subtopics. Okay, now first about the power system transients. Here, when a transmission line is connected to a voltage source, when an voltage AC voltage is applied to the transmission line, what happens is the whole of the transmission line is not instantly energized. Okay, when supply is given to the transmission line, the thing is the line is not, the total line is not instantly energized. There is some time elapses between the initial and final states of the line. There is some time between initial and final steady state of the system of the transmission line. This is due to distributed parameters of the transmission line. So we know that line parameters, transmission line parameters are R, L, C, resistance, inductance, and capacitance. So due to the distributed nature, so we know that the resistance, inductance, capacitance are available along the total length of the transmission line. So we say that they are distributed parameters, distributed in nature. Okay, so that is the reason. So that is the reason why there is a some time gap between the initial and final state of the system. Now what is the point is here? This process is similar to launching a voltage wave which travels along the length of the line at a certain velocity, the point. Okay, so that is a point. Okay, this process is similar to, okay, a traveling wave launching a similar to launching a voltage wave which travels along the length of the line at certain velocity. Now the traveling voltage wave is also called surge. Okay, this is, okay, traveling a wave along the transmission line. They are also calling it as a surge. Okay, generally this surge may be caused by switching, okay, or lightning. Okay, we are doing continuous switching on and off. Okay, various equipment. Okay, which are connected to the transmission line. Okay, we continuously do the on and off operations, and also due to the lightning phenomena which generally occurs during thunderstorm weather conditions. Okay, so this traveling a voltage wave along the transmission line, they're also calling it as surge. Okay, this is nothing but a surge which generally occurs due to switching, okay, or lightning. Now, the voltage wave is always accompanied by a current wave. So we know that if there is a voltage in a circuit or in the line, transmission line, automatically there is a current also present. So here we are talking about the wave, traveling wave. So the voltage wave is also always accompanied by a current wave. Now the surge reaches the terminal approach, such as, okay, whenever it reaches the its end point, where generally there are cable boxes or transformers, various switchgear equipment, okay, which are always present, which may damage if they are not properly protected because of this surge. Okay, this may happen. Whatever the equipment connected in the transmission line, they may get damaged if they are not provided with protection. So, what the point is, finally, as the waves travel along the line, their wave shapes and magnitude are also modified. This is called distortion. Okay, so here the voltage wave, traveling voltage wave or current wave during, okay, along the total length of the line, what happens is their wave shapes or magnitudes, they may get modified. This is, they're calling it as distortion. Distortion. Now, one more point is, the study of traveling waves helps in knowing the voltages and currents at all points in power system. Okay, what is the use of? What is the use of this studying traveling waves is, this helps in knowing the voltages and currents at all points in the power system. Now, it also helps in design of insulators, protecting equipment, and the installation of terminal equipment and overall installation coordination. Okay, this is the use of the, okay, studying about traveling waves in transmission lines. Now, types of this transients. Okay, types of the transients. They occur in power system in transmission lines. Depending upon the speed of the transients, they can be classified as extremely fast transients, extremely transients, which generally occurs due to surge phenomena, that is lightning and switching. Next, medium fast transients, which generally occurs due to short circuit phenomena. And third one, slow transients, which is due to mainly, which is nothing but transient stability. Okay, during the, that means minor, small variations, maybe on and off. Okay, short disturbances. Okay, transient